Bongan. I am a graduate of NIT Surathkal, NIT Karnataka. I am 83 batch, electronics branch. I am currently the Senior Director Marketing at Atrenta. It is my great honor to introduce Dr. Ajoy Bose, the Chairman, President, and CEO of Atrenta, the largest private EDA, electronic design automation company. Not because he writes my paycheck every 2 weeks, because he is one of the most respected semiconductor industry leader, a well-respected entrepreneur, and also a thorough gentleman at heart. Ajoy received his bachelor's from IIT Kanpur in electrical engineering, and his MS and PhD from University of Texas at Austin. For once, go Longhorns. He began his career at premier AT&T Bell Labs at Murray Hill in New Jersey. From AT&T, he moved on to Cadence Design Systems, where as a vice president of engineering, he led the team that developed Verilog simulation products, which became the global standard for complex chip design simulation. Prior to Atrenta, Dr. Bose founded and incubated several companies related to EDA, digital video, and IT services. He seeded the Atrenta's flagship product, Spyglass, which has become the industry standard in RTL analysis. Please help me welcome Ajoy to the stage to share his thought on semiconductor challenges.
Thank you, Ramesh. It's a great pleasure to be here. I appreciate the opportunity that you all are providing me to share with you some of my experiences and my thoughts about the trends in the industry. So what I'll do is, let me figure out first how to operate this. So my presentation is, yeah. Thank you. So what I'm going to talk about is centered around this concept called an SoC. I'm sure many of you are familiar with what it is, but some of you may not. So I'm going to expand on it, and I'm going to talk about some trends centered around SoCs. So SoC stands for System on Chip. And it's the way most ICs, integrated circuits, are being designed today. The key concepts of an SoC are that as opposed to the classical way of designing an integrated circuit, where you would design a big function as one block, SoCs are more based on putting little blocks together that implement different functions. So it's kind of like a game of Lego that your kids probably play with. And it does provide an interesting opportunity to bring about different functions that you may not have, you may not need all the expertise, because you can get these blocks with these different functions from various sources. So SoCs have become a major driver for innovation in the industry, and a major driver for the business of semiconductors. So I will expand on why I feel this way, what are some of the trends, what are some of the challenges, and how all of this is driving, innovation and growth in the industry. I'm going to talk a little more actually focused on the design side of things. And my friend Jim Hogan here is going to tell you how you make money on it, and that's a much tougher problem than designing them. So the key thing about SoC is that it's in some ways it is a piece of semiconductor, and people that make them are your typical semiconductor companies. Now these are some of the big names, and I'm sure you're familiar with these names, and they used to make ICs in the past, they make memories, and they make SoCs today. But the interesting change, the interesting trend is look at who is now consuming SoCs. Now, these are people that, as of a few years ago, really had not much to do with semiconductors. They were focused on software, or if they build an electronic product, it was based on using components that were available off the shelf. But all of a sudden, in the last few years, these people have recognized the benefit that SoC can bring to them from a business point of view, from a differentiation opportunity point of view. And when you have such giants now recognizing the value and the power of SoC, it becomes a disruptive influence on the industry. And that's the story that I'm going to talk about today. So, do you have a clicker by any chance, Ramesh? No? That's all right, don't worry about it. I'm just going to move it so I can stand a little further away. And don't worry about it. It's okay. I've got this worked out. Don't worry about it. That's fine. That's perfect. It's totally okay. I can manage to click and talk. So, okay. So the reason why SoCs are becoming very popular with the companies of the likes of Apple and Oracle and others is that increasingly these companies are recognizing that they can capture kind of their uniqueness, their customer experience, their value in the SoC. And they can do it in a way that they can protect their intellectual property, their innovation. So it becomes a channel for them to funnel a lot of their creativity in, that ultimately ends up as the differentiation and the uniqueness in their system products. And these, of course, have become an ecosystem, and I'll describe the ecosystem in more detail. So, as you know, that chips are now everywhere. They are in your cars. If you have a high-end car, you probably have 150 microcontrollers in your car. There's medical applications. There is, of course, huge application in consumer and entertainment and so on. So it's become a very widespread. Thank you. Great. Yeah. Yeah, it's some slideshows. Yeah. Thank you. Yeah. So they are truly getting into most products that that touch your life, and we are still at the beginning of this trend. There are many, many more places where SoCs will play a role. In fact, one of the Japanese companies that I'm quite familiar with has a program to design 1,000 unique SoCs targeting the China market over the next few years. And there are, there's a lot of smart things around, right? Smart grid, smart car, smart home. And these people think of it as a smart society. And a lot of that smartness is going to come from SoCs being in everything that becomes smart. So it does present a significant opportunity for the semiconductor industry. And that the best thing that the semiconductor industry can do is to make it easier for the system companies to design SoCs, use SoCs, make it more affordable. And that's the theme of where I'm going with my talk. And SoCs do represent good benefits. There are good margins for people that make the semiconductors, and there are, of course, in many, many applications, you need many, many units, so you can sell many of them, and these are all business-wise a very, very beneficial and a very compelling reason to use SoCs. So the SoC is quite different from the traditional integrated circuit. they look more like this. Instead of, if you look at an old integrated circuit, it's like a lot of logic kind of in one large block. Here you can clearly see that multiple blocks have been used to put together this design. And typically, there are multiple processors, multiple CPUs. There is typically a signal processor, a DSP. There is a graphics element. There are fabrics. Fabrics, by the way, is a term for the buses that are used to interconnect these blocks. So it's what provides the interconnect between the blocks. And then there are many what are called IPs or intellectual property. These are just another fancy name in the industry for blocks. And these things together make up the SoC. And most often, these are being fabricated by TSMC, which is the giant foundry in Taiwan. Okay. Now, there's a couple of things that are interesting to observe here. You have, for example, a large graphics block, and if you are creating a product and you want to have some really cool display in the product, but you don't have to become an expert in graphics. You can go and license one of these things from several possible sources. You can put it on your chip, and lo and behold, your product now has very cool graphics. And that's the power of the SoC. So you don't have to be an expert in all these things. You can have video, you can have audio, you can have various different interesting functions without really having to have a lot of that expertise in your company. Now, the two major players here are ARM and TSMC. These are what I think of as the 800-pound gorillas. They're kind of like the two anchor shops in a large shopping mall. They represent a very significant influence over this whole ecosystem, and they have their own ecosystems. So ARM and TSMC is available to everybody, right? I mean, you can go license an ARM core, and you can take a design and take it to TSMC, and they'll happily make it for you if you give them whatever money they want. So how do you differentiate yourself, right? That's available to everyone. So you start differentiating using these little blocks that I show here. These are some peripheral blocks. They have some unique functionality that you create. And more, the differentiation is coming through software. Companies like Apple and all have demonstrated that you can get significant benefit in the SoC by having really powerful software. In fact, it has now come to a point where the industry has kind of reversed itself. It used to be that you design a chip, and then the software guys would come in and write software for that chip. Now the software kind of exists, and you design a chip that will run that software. So the requirements have inverted. And the other way you differentiate is by focusing on improving the performance of the SoC on
You got embedded audio.
yeah, exactly. So you differentiate yourself through improving the power, performance, and area of your chip. So if you can reduce the power consumption of your chip compared to your competitors, then you have longer battery life, right? And that makes your product more appealing to the customer. So SoCs are cool, right? I mean, they're being used by some really high-powered companies, the giants of the industry. SoCs are, offer these neat advantages of being able to put some neat functionality together with modest effort. But there are a lot of challenges around SoCs. So that's why isn't everybody adopting them at the kind of pace that you would expect? That it's a no-brainer, right? Everybody should be designing SoCs for everything. Well, the challenges that face SoCs are, first of all, mostly a lot of it is around the business side of it. They are very expensive, and they have in most applications they go into, there is a very significant time to market pressure. So you have to design them in a cost-effective way and do it very quickly. The second challenge is, I would call them technology-related challenges. People are putting more and more transistors on one chip, and so that means they try to go to smaller dimensions for creating these designs, and the smaller dimensions come with various problems. They have a very common problem around power, has to do with what's called leakage. The transistors leak, and the smaller they get, the leak, like a sieve. And you've got to do all kinds of clever things to manage the power of the chip. So these technology challenges get worse as you put more transistors on a chip. Complexity, now people create chips that have 1 billion plus transistors on them. That's a mind-boggling number. When I started life, we used to count LSI chips with a few thousand transistors on a chip. So, as you can see, it's gone up by a factor of 1 million. So it's a huge growth in complexity. And given the cost pressures, you've got to deal with the complexity without spending too much money to solve these problems. And then there are some emerging industry trends. The industry likes to do things in a certain way that are convenient for them. So that's, and there are some interesting trends that some of you're familiar with, but it does present a new set of challenges. So let me expand on a few of them, and I'll go through these quickly. So if you look at the cost, at each new technology node, we call these things technology nodes, and they are typically in terms of some number of nanometers. So 65 nanometers, 45, 28. These are typical technology nodes. At each step, the cost of a design goes up, and we are hovering at a point where a SoC design is in the order of $100 million, in round numbers. That's a lot of money. And not only are they expensive, but they are high risk. You rarely get them right the first time, which means you have to assume that you'll have to make it a couple of times to get it right, which means another another round of expenses, if you will. So if you are going to spend $100 million to design a chip, then that chip has got to service a market that's got to be many times larger, right? So you're looking at a market where, which is $500 million or so, $500 million, let's say. There are not a lot of applications that have that kind of volume. What that means is, as we get to these cooler, neat SoCs that are fancy and small dimension and large number of transistors, there are fewer applications that can afford them. So the more you can do to manage the cost of a design, the more applications it can go into. So, as this slide shows, as you can see, the cost keeps going up. So the market required to justify that SoC has to become larger and larger. And there are not a lot of applications that have that large market. The other challenge that people face creating SoCs is that there is now a significant amount of software that has to go in to complete the SoC. So a chip company is no longer a hardcore hardware semiconductor company anymore. You'll probably find more software people in a chip company than you'll find hardware designers. And that is because the SoCs are required to come with a lot of software to enable that SoC. And the more of it you can put with the chip, with the hardware, the more differentiated you are, the more compelling your product is. So for example, there are companies that make SoCs for cell phones that provide a lot of the software, to make it into a cell phone. And then there are companies in China that would buy that SoC. It comes with the software, and you put in a power supply, and you put in a display, and you put it in a case, and you have a cell phone. And that's how you have this proliferation of cell phones that are flooding the markets of China and India, is because it's relatively easy to make the cell phone, getting a chip that comes almost ready to be made into a cell phone. some interesting emerging trends in the industry. So first of all, as you all know, the workforce is getting very distributed, and given the nature of these things, where you're assembling blocks, well, these blocks can be designed in different places. So it's not uncommon that you have an SoC that has a block that is being designed in Bangalore, and another block that's being designed in Santa Clara, another block in Munich, and somebody has got to assemble them together to make the chip. The other trend is that there is a growing market and a large market in these blocks or IPs. And there are some names here, but it's everything from small mom and pop companies, mom and pop shops that make these blocks, to large companies like ARM or Synopsys that are big providers of these blocks. And then because things are so expensive, people try to be clever. So they try to design what are called derivatives. And what that means is that, you kind of partially design a chip, and then you make little changes to target different applications. So I can design a chip that has to cater to a low-end market, and I might have, some low-level graphics. Let's say 32-bit. 32-bit is not low, but let's say a low-level graphics. And then I want to sell it into a higher-end market. Now I want to put a 64-bit graphics block in there and sell it to a different market. And this has become a very common trick. So based on one architecture or one platform, as they call it, people create many derivative products. So this has become another big trend, and all large companies are scrambling to get better and better at creating derivatives. And then the system houses, ultimately, these are the people that make the end product, the likes of the Canon or Sony and so forth. They are very influential in this ecosystem, and they have some of their ideas that are impacting this industry. So I'm going to show you, expand on a couple of ideas. So this is the concept of platforms and derivatives. I mean, they look roughly like this. You have a systems company that will do a few special blocks, and it goes into a platform that's typically designed by the semiconductor company. And this is your partially designed chip, which has some room for you to drop in some blocks, and you can pull out a block and put in another block, and you have created a new design. And these guys have requirements that are not very dissimilar, but it generates a lot of pressure and demand on people that create the blocks and create the platforms. So everything from some consistent methodologies, so error-free blocks and various other, fairly, they want good handoff. So there is a point where somebody's going to design something and hand it off to someone else, and you want some kind of a check at that point. So these are all kind of emerging trends that are driving a lot of activity in the industry. The system houses, this is your Canon or Sony-like companies. They are the big, kahuna now in this industry. So they want more influence. They want to exert more control over the SoC, which has historically been, not the case. I'll give you another example, car companies. Car companies traditionally wanted to not get involved with semiconductors. They would outsource the whole thing. Find somebody, contract them to build your chip, write the software, bring me back a little box that I can plug in and becomes, my electronic carburetor, or, becomes my, goes into and supports my brake system. Now all of a sudden, these guys want to play a bigger role because they have more exposure, right? I mean, you remember some of the quality issues around cars. It becomes ultimately a liability for Toyota or whoever. So they need to have more control, more influence on this ecosystem. So that's a changing trend. So all of a sudden now you have these big guys worried about semiconductors, which didn't happen before. They want vendor independence. These guys are looking for the cheapest, fastest, most reliable supplier in the world, and they keep the semiconductor companies always on their toes to get the best deal. And the way you do that is you can take a design and go from one company to another. So you can effectively have a very powerful bidding system. And they want that because it gives them the advantage of cost. They want to use different blocks from different sources, and they want unique blocks, special blocks. And then they want visibility and tracking. If I'm Canon and I've got my chip being made by some semiconductor company, say in Japan, I'd like to know exactly where that chip is. Are those guys on track? Is that product going to come out? Is that chip going to come out in time so I can ship my digital camera, the new model digital cameras before Christmas or whatever it is that I'm trying to do? So there's huge dependency that these system companies have on the chip. So they have this big need now for visibility and tracking. So, again, a lot of interesting, exciting opportunities around SoCs, but also come with a lot of challenges and a lot of disruptive trends that they're creating. So just at a high level, the summary of the challenges are, the costs are very high, the respin rates, which is a way of describing how many times you'll have to redo it because you made a mistake, they are pretty high. Reuse is quite critical, and finding the right kind of blocks that can help providing your functionality and using them effectively is not as easy as it sounds. It has its difficulty, and it's also costly. The silicon vendors, the IC vendors now have to offer more of the complete solution. So now all of a sudden they have software developers that outnumber the hardware developers. And you want these things to be done in a way that you get the design right, you get a lot of confidence on your design. You want to make sure that it meets your power, area, those requirements before you commit to detailed design. Because design is very expensive. And once you go down the path of doing detailed design, making changes is expensive, finding errors and fixing them becomes very prohibitive, it's risky. So you want more and more of these things to become visible early in the design. And you want the ability to explore the design space so you get the product to a point where it is what you want. So one of the most interesting trends and interesting concepts, I should say, that has emerged in the last few years is the result of a white paper published by Cadence, and it's called EDA 360, so I want to give Cadence a lot of credit for this concept. And what they did was they looked at this whole space. They said, you know what, you can divide it into 3 clean segments. The first segment is what they call system realization. And this has to do with now this big chunk of software that is now part of the SoC ecosystem. It's the operating system, it is the application software, and that's all a part of system realization. In some ways, it's not a very new concept. People know how to write software, and they have known how to do that for a long time. And there are people that write, lots of software. And that's how they specialize in that. But it is still, in the context of a chip, you have to recognize that it is a special domain. The other domain that they define is what they call silicon realization. And this is the traditional business of creating silicon designs, or IC designs. These are tools like synthesis and what's called place and route, which does the physical design. So these are all more traditional ways of designing a chip.